Welcome back to the Manufacturing Come Up. I'm Malachi Grab, host of the Manufacturing Come Up. Today, we have a very special guest today. Not only is she the program chair of the robotics program at Ivy Tech, but also my professor and one of my mentors that got to me to where I'm at in my career today. How's it going, Donna?
This episode of the Manufacturing Come Up is sponsored by Elite Automation.
Elite Automation is a systems integrator specializing in robotic weld cell applications, and especially the design and manufacturing of the weld fixture.
If you have any robotic weld cell needs, you can reach us at rfq@eliteautomationusa.com.
I am so excited to be here. Malachi, you have grown so much since you were a student here. It is fantastic to see where you are going. I can't even say it's fantastic to see where you've gone because you're not there yet. You're still going. You're
Still going.
fantastic.
Yeah. I mean, I completely changed. I mean, I remember there was like one semester where I was working like I had to stay up for 48 hours before I could go to sleep, and I would wear like wife beaters to to the class sometimes just because like I was going like straight from work to school all day and then back to work again.
I don't remember any of that about you. What I remember is that when I was teaching something, we've got technology equipment all over the place, and sometimes it doesn't behave. So when something would break down, and I'd usually say, okay, class, I need to stop and fix this here, or maybe you guys can go on break. I need to see what's going on here. That's when you would really come alive. You know, you were a good student during the other times, but when something broke, that's when you really wanted to dig in, and you stayed through the breaks. You wanted to help me figure out, well, what's wrong with it? That's what really sets you apart.
Yeah, thank you. I think definitely for me, like a big part that I guess set me apart a little bit is like I was at a point in life where I was just ready to take things like seriously, and I just knew like the educational aspect of it and me actually knowing stuff whenever I graduated was so important.
I've seen a number of students who have come back to school. Maybe they didn't do so well the first time they were here. There's a couple students that I remember as not doing very well. I'm not talking about you at this point, by the way. But when they came back a couple years later and indicated, yeah, I'm ready now. Now I understand the seriousness of it. Not saying that it's all a serious time, but this is training you for your future, for your career. And they buckled down and listened a whole lot more. And they were entirely changed the second time I saw them.
Awesome. Yeah, it's super powerful. So let's go ahead and take a dive back into your past. And if you wouldn't mind, like telling us what got you interested in engineering, what drove you to go to school for engineering?
Okay. Well, in school, I did well. I was I enjoyed the math and science. I did well in those where other people said that they were struggling in that. But for me, it was looking at gadgets. I was always interested in taking things apart and seeing how they worked. So that was a natural thing when I saw engineering design things. I was always trying to make things up out of my, little pipe cleaners and clothespins and art supplies and that, trying to make something that would really work. And so engineering was a good fit there with education and that hands-on. Now, I would say back in the time when I went to engineering school, it was thought of as a higher prestige job than engineering technology. And as I got many job offers in engineering as I graduated, I realized that engineering technology was not really just seen as good, when really I think the education there would have prepared me better for what I wanted to do, which was work in manufacturing, work with equipment. Engineering would have been better if I wanted to be theoretical and be on the computers and do the heavy math to get ideal designs in that, but I wanted to play with stuff. I wanted to be on the equipment. These days, I think things have turned around a bit. not only is engineering technology really seen as a good job now, I don't see that distinction anymore, but also I'm seeing a lot more people recognizing that technology and manufacturing, maintenance, those terms are not the dirty words anymore. Those are awesome jobs.
Yeah.
We see people who have associate's degrees making a ton more money than I make as an instructor. And I think people are really seeing the value in it. Plus, when you can say, I look at these people and say, that's a job I could be proud of. That's a job I could see if my kids took that job, I would be proud of them. I think it's getting a lot better reputation nowadays, which is great to see.
Yeah, absolutely. I think that so many companies have realized that, one, like, people they get these engineering technology degrees and they come out a very skilled individual. And also I think that a lot of colleges lacked on the engineering side of things, where there's so much theoretical and pretty much like no practical, especially practical when it comes to like working on the exact thing that they'd be working on. Like, one thing I see out of engineers is they'll work with like a software for like a couple of weeks, and then after they work with that software for a couple of weeks, they move on to another software, and they never really gain any like true experience with that software. And that,
There's different theories on how you can do things, because when you look at a bunch of different softwares, you see that there are similarities. And when you've learned a couple of them, then even if I see a system that I've never seen before, I know how to ask myself the right questions. Okay, I need to do a for next. I don't know how to do it in this software, in this syntax, but if you can lead me to where that is, that's what we need to do to get this going. So with the engineering school being very theoretical, that's very important for higher level research, for looking in depth on things. I thought it was a great education and I love what I did there. I wouldn't have changed that. But I do think there's other avenues that are better for certain jobs. And even though I love the path that I took, an engineering technology would have let me see the equipment hands-on much quicker in my career than I did. It's one thing to do diagrams and calculations on the fluid flow through pipes and pumps, but if you can't recognize, oh, that's a pump sitting in front of me, then I'm lacking a little bit in my education.
Yeah, that makes sense. What was kind of the driver for you to go for an engineering degree?
Well, you're going to love this answer. What happened is I was an undecided major, and I got a letter in the mail saying all undecided majors had to come in Wednesday night for a find yourself workshop so we could look at the different careers and figure out what we wanted to be. And that didn't sound like any fun whatsoever. So I said, I'm not undecided, I'm an engineering major. It had been what I was considering, but that's how I actually made my choice.
Gotcha. It's kind of funny how like little things like that in life will pop up that kind of like potentially shifts where your life goes.
Yeah. Now, I will say I highly advise anyone going into a technical career to get an internship, a part-time job, a co-op, whatever you want to call it. Get out there and get some experience for a number of reasons. One is, as an intern, you're not necessarily expected to be making this your life choice. So you can try a company. Boy, I can't really picture myself working here all my life. You're not doing that. You're working there while you're in school. So you can try things out that you might not think you like and then find out, wow, I really did. You're seeing other people on the job as well as yourself as you're being shown what the job really is. You see that person in their role, I could never do that job because of whatever trait about yourself and whatever trait about that job. But then you see other people and say, now I like what they're doing. And you just learn more about the job. You learn about yourself. You can test those things out. And we can see, as instructors, we can see a huge difference in students when they're working in the industry and when they're not, because they just are able to absorb so much more. They see the big picture out there. They're seeing what we're saying and how it relates. So I highly recommend getting some work experience, because when I was taking my freshman level classes and I had the gen ed classes, the physics and the chemistry were not really for me. They were okay, but I couldn't see myself doing any kind of a job in that for 40 hours a week, not to mention overtime. But then when I went as a co-op, I could see what engineers did. And I said, yes, there's jobs that I really like. And I preferred the ones that were out on the floor with real equipment rather than the ones sitting at a computer doing finite element designs over and over.
Yeah, absolutely. It was one thing that had a huge like multiplier effect on my knowledge when I was in school. You know, obviously like working with a systems integrator, can't get much better than that as far as like real world experience with the degree path I was going towards, and just seeing what I was learning, how it actually applied to on the job, and then on the other hand, like running into issues on the job, and then being able to go to school and say, hey, have you ever ran into this? Have you ever seen this issue? Was like super powerful. Also, Saeed said hi.
Hi, Saeed. You got to stop by and see me sometime. Miss you.
This episode of the Manufacturing Come Up is sponsored by Elite Automation.
Elite Automation is focusing on AMR technologies. AMRs are autonomous mobile robots used in your facility to transfer goods or products from one side of your facility to the other.
This is a super powerful tool, and it's a new piece of technology that us as systems integrators can utilize as a tool to leverage your company to be more advanced than the next company and be able to automate systems that at one point were not able to be automated.
If you have any AMR needs, you can reach us at rfq@eliteautomationusa.com.
Yeah, I think he's doing pretty good.
Awesome.
He got married and everything. Yeah.
Yeah. Well, that's a great guy, and I do believe that he is one of several that have come back and said, wow, I thought you were tough on me in school. I thought that, you really pushed, and, that made me uncomfortable. I didn't want to dig into things that far. And now he sees how just trying to help him and others learn. And when you get out there, it's going to be even bigger. You think I'm pushing you hard. Look at all that knowledge that there is that we didn't have a chance to get to. And just seeing the road to success that he and others are on is just fantastic to see.
Yeah, absolutely. So what drove you to, I guess, select the job that you selected once you graduated, or did you take an intern prior to graduation?
I had 2 different interns with different companies. Again, I thought that was great that it gave me different experience. I got to move out of my hometown to work for one of those, and that was nice because I could see just a little bit of cultural differences, the differences at different factories. One that I worked in was a headquarters of the company, and then I got to take a trip out to one of their plants. So seeing different ways that things worked. Both of those companies that I worked for were ones that I interviewed with when I was looking for the full-time job. And both were legitimate contenders there. But the one that won me out was one that allowed me to get hands-on. It was doing design work for nuclear power plants. When they were down for maintenance, we would design robotic tooling to go into the steam generators and do repair work. What was great about that is I designed it, I have a test lab, I test it, and then they ship me and the equipment out to the site to see it, to use it. So that was really great. I had seen as a co-op sometimes, especially at headquarters, I design something, it goes off. I wonder if that worked. and never really got any feedback.
Yeah.
So it's good when you're the one who has to repair it when it's broken. You learn quick what not to do. And I'm going to put the time in to make sure this is better next time. Because I remember sitting on the floor of a containment building, 3 sets of gloves trying to solder on little tiny parts. And it took hours.
Yeah.
3 sets of gloves.
Yeah. Yeah. Whenever like, an engineer gets to get involved in like the assembly process, they look at it and like, huh, kind of wish I would have designed that one differently. So like,
we had a machine shop in our building, and they would not hesitate to call the engineers down and say, okay, so you're asking me to machine this, and you referenced it off the part that I just already cut off in the last step. How do you want me to do that? I'll rethink that one. So got along great with that group and really appreciated that they let you know what you needed to work on.
Yeah. Yeah, that exposure is great. So whenever you were at this nuclear power plant, I guess, how long were you there for you like transpired and to move on to new things?
It was 7 years.
Oh, wow.
And loved that job. Things started moving with the economy. Things weren't looking real good in the nuclear industry, and most of the people that I worked with have since scattered and gone other ways. It really downsized in that department. But I did love that. I moved up into this area at that time. I took a consulting job and found out that sitting at a desk was not for me. I can't sit still. I want to be playing with the equipment. So I got a job as a project engineer. And what my job was to look at all the equipment in the factory or on my particular line and either make repairs to make it perform better, not fix it, because maintenance would do the patches and fix it and make sure that it was running again. But okay, this one keeps breaking, or the operators are finding it hard to make their settings, improve those. And then also brand new machines that we would come in to replace some of the older ones or to do new capabilities, things like that. Gotcha. That was an awesome job for me. I got to work with the equipment offline. I got to talk to the operators and maintenance and say, if I change it to do this, is that going to be better for you? And they would let me know, no, I still would have this problem, or this part here I really like. And again, test it out. And if it's not performing like I had designed it to, then keep working on it until I got something that was better for the operators.
Nice. Was this at PGW?
Yes, it was.
All right.
Didn't know if we were allowed to list names and that in there.
Yeah. Well,
now I got moved after a while. That was an excellent role for me. I got moved later to become a process engineer. And in that job, it wasn't the best fit for me. That would be one where when the process is breaking or broken, you'd get called to the line. We're starting to drift one way. What's going on? The machine broke. What's going on? Work with maintenance and get it fixed. So with that, I personally found that to be much more of firefighting. We got to get this up and running. So while I wanted to, let's step back and let's look at the root cause. You can't do that. You got to get it back up and running. So I preferred the let me step back kind of role. And I think that's a matter of just learning who you are and making sure that you get in the right fit. Because certainly I saw people who, I don't think this person's very good. They're not good in this job. You get them in a different job and all of a sudden you see, wow, that person is fantastic. Yeah. So whether it's you or someone who works with you, make sure everybody is in the right role for themselves.
Yeah, absolutely. That was kind of one of the things. Part of it is just my experience, but like I did a lot of work on capital projects. And so like whenever it came to like on-site troubleshooting, like most of the systems that I was on-site troubleshooting throughout my career were systems that I had developed, or, I know the engineer that developed it, and, kind of know like their programming structures and like and how they go about programming. And with that being said, like I didn't have like a ton of experience in the programming and of lines being down, right? This line's down. I need you to find out, where the issue is and get it resolved quickly. So when I was in those situations, like I handled them okay, but I didn't like them at all. Like one time I got sent out on an emergency call, and one of the plant engineers is sitting there with a stopwatch, and I'm like, I look over, and I was like, are you stopwatching me? And he's like, yes, I am. And I'm like, oh gosh, that's not, can you like do that over there where I don't see you stopwatching me or something? Like, it's crazy. I mean, because they were like, with these big plants, whenever it's, $20,000 an hour or whatever for a line to be down, like they're clocking minutes because they need to know how, there's $2,000, there's $5,000, there's,
I don't know how much people can develop certain skills, but one thing I've noticed about the successful maintenance workers is they are able to just tune out. People are behind them saying how much this is costing us and when is this going to be fixed and all that. And they just are able to brush it right off and say, let me do my job. They focus in on trying to find what the problem is, despite maybe too many people trying to help behind them.
Yeah, absolutely. Absolutely. And if I'm not mistaken, this was kind of the connector of you linking me up with Brian, right? You worked with Brian at PGW.
Yes.
Yes.
Yeah. Brian was the guy who could run the robots, and when something had to be modified, when something went wrong, Brian was the one to call. So when he went out and started his own company, we still went to Brian to have him come in and fix everything.
Yeah, I mean, he was servicing PGW for like, 20 something years, right? Probably like 30 years at this point.
You're dating me here. I'm not. It can't possibly be that many years.
You're not going to agree.
No, can't agree with that one. Can't agree. No.
Yeah.
Seems like just yesterday.
Yeah.
But I do remember some of the backups. We couldn't do a backup on at least one of his programs because we had a floppy disk drive on it.
Yeah. Yeah. That's crazy. Yeah. Like some of those like RH robots, like those were old as dirt. Like it had the PC control.
Yeah, that keeps evolving, and that's an interesting thing about teaching here is you teach a class, and again, I started 15 years ago here, and a lot of the lessons that I worked on back then, I've totally had to throw out because we just don't do it that way anymore.
Yeah. Yeah. I mean, like with say for instance, that's one of the biggest things between like an older robot and a newer robot is like the software side of things. Like there's so many more tools that are built in now to where like you would have had to write like some specialty program to do particular things that are just now built in as a function to the robot.
Yeah, well, in fact, just yesterday we did a lab where we showed palletizing. So basically, if a part comes in, we're going to have a robot stack them first, do a row, then do the rest of the columns, then go up a layer and just be stacking things on top of the pallet. Now, in previous years, and maybe when you were here, we would have taught that as individual steps, individual moves. How can we make that quicker by saying, hey, each one, if we move 50 the first time and the second and the third, how can we make that into a loop to save some programming?
Yep.
Okay, that stuff is still pretty good basics, but now we go in and say, okay, we're going to palletize, and it does almost all that work for us. Yeah. So people were able to do a program in less than an hour when they had never seen it before, as opposed to the old way they would have taken at least the full 4-hour class, if not 2 classes to do that.
Yeah, and like with like palletization, like some of the code is like we'll write for some projects where you can enter the box dimensions and tell it how wide you want it and how long you want it, and it'll basically do all the calculations and adjust all the positions for just the HMI recipe that you put in there.
Yeah. That, I don't think that was around back when I started on it, and certainly we didn't have access to it, but it just got added into our curriculum this semester.
Nice. Yeah, it's definitely a super powerful one. Palletizing is a big deal. I think any company that needs any company that can use palletizing will have palletizing.
Yeah.
It's like,
I remember back at PGW, or PPG as it was back then, I was walking by a line and someone called me over. It was the production manager, and he said, "Look at this backlight, the back window. What do you see? Do you see anything wrong?" Obviously, there's got to be something wrong with it, or he wouldn't have called me over. So I'm looking and I'm looking, and finally it's like, "Oh, just forget it." And it was a huge blotch that was missing out of the silk screening that was supposed to have happened. And I didn't see it. The operators, the inspectors had missed it. Everybody had missed it. And once you see it, it's this huge defect. How in the world did we miss it? Well, then I'm at a tour many years later at Mead Johnson, and they're doing bottles of Infamil. 700 a minute are whizzing by. I can't even see the bottles because they're all blurry going by me so fast. But they have a vision system that was taught to look for the bottle and look for the cap, and look and make sure the cap was on, make sure the cap was not cross-threaded. So they were checking the height to make sure that it was down far enough, not down too far. And 700 a minute, this vision system kicked out a couple of them while our tour guide was talking to us. So he pulled them out and he said, "I wonder what's wrong with this one. Must be something wrong." And in about 15 seconds, he was able to identify the defect on there. Think of that manufacturing process if everybody had to have a minimum of 15 seconds to look at each bottle as it's going by. Not to mention the fact that you get tired. The last 699 were fine. I'm just assuming this one's fine. Don't look at it long enough. So vision, you can probably talk about how much of a difference that has made.
Yeah, absolutely. I mean, vision, it's one of the most powerful things that automation has had. I mean, there's a lot of processes that can't even be automated without the vision side of things. Like working with Brian at Midwest, one of their core competencies was vision, right? Their proprietary vision systems for, vision location and vision inspection. And in reality, like, we're better than the Keyence and Cognexes of the time. Like, that should have easily been like, $100 million company just for that product alone. Because it's so powerful what it can do for the industry. Yeah.
And I mean, there's sometimes you talk about robots replacing people, and sometimes when I'm looking at how I'm going to have this robot pick something up, I think about, well, how would I do it? How would a human do it? What would those motions be? But sometimes we have to look past that and say, well, humans are limited, and vision, especially with the speed and accuracy involved, you can do so much better than a human can do. When you're looking at setting up the robotic end effector, you're not limited to 2 hands and 5 fingers on each. You can.
Yeah, it's pretty much limitless.
Yeah,
absolutely. So I guess you had your position at PGW. You worked there for how many years?
I think about 7 years.
7 years, and then from there, did you transition into the education space?
Well, sort of. I was laid off from there, and I think before there was a lot more of a stigma about being laid off, but nowadays so many people have been laid off. I want to encourage again anyone who feels like, well, I was laid off. How am I ever going to get another job? And you think all the negative things on that, and I certainly did. Well, if you look at how deep they had to cut And the role I was in, which was a process engineer, it wasn't the best fit for me anymore. And so I can't say I loved being laid off, but I think it was time for then me to look into making a change. At that point, I had 2 young kids at home, so I tried the stay-at-home parent thing, and that's not for me. I went very, very stir crazy, and I love my kids. They are fantastic, but I wanted to grow intellectually. That was an important part of me. And
Yeah.
so I came to Ivy Tech and started as an adjunct and loved doing that. One thing I found is that by having the resources to be able to make this content and talk to other instructors, we're a statewide system. So when I get into a problem, I can talk to the people who sell the equipment. I can talk to the engineers that I've met along the way. I can talk to the other instructors statewide and the instructors in other areas here. I found a lot more resources to find the root cause of problems, to really learn about things. So about 2 years, I'd say, as an adjunct, a full-time position opened up. And at that time, my specialty was mechanical and quality. But I was asked during the interview, would you mind learning more about the robot programming and the PLCs, which at the time I had never been a PLC person. I looked over the shoulder of the PLC programmers and asked them pesky questions. Well, why are you doing that way? Well, what does that do? Let me get some work done. But I had questions there, but they said, would you mind learning about that? And I said, I would love to learn about that. So they sent me to some classes. I sat in on some of the classes here until I got qualified enough to teach them, and probably taught for about 10 years before I really felt comfortable now making some changes in here. And okay, I know enough to start moving things around a bit.
Yeah. Yeah. You can start also seeing like just the real world impact of like what's really important to learn.
We have advisory meetings, minimum of twice a year, and I go to career fairs and plant tours, things like that, try to get our students out to see people. And I'm always I'm looking at what new technology is out there so that we can keep up. And I am asking what is important. Certain people come in saying, I want to work at Toyota. And so I've talked to Toyota and said, if someone wants to come and work for you, what do they need to do? And for us, it's the industrial technology program. You need to get your degree, then you can test for maintenance. We have additional classes that you can take to get a second associate's degree in advanced automation and robotics technology. That's what you got. And that broadens you so much because, to get a 2-year degree, there's still more out there to learn. Even after your 75 credit hour degree, there's still a lot more out there for you to learn.
Yeah.
But what do I need to get in the door and then keep learning and keep growing?
Yeah, a big thing for me is like I wanted to be multi-disciplinary. So like I got the electrical and mechanical concentrations. And another big thing for me too is like in reality, like I definitely had insecurities, about being able to get a job and all that. And one of the big things is like career or resume building, right? I wanted to have like the most solid version of a resume that I could have. I knew that like, okay, well, if I had multiple concentrations and somebody didn't, if I had 2 degrees, they had 1 degree, at least on paper, there would be some things that stood out and gave me a little bit more of like a fighting chance.
Interesting, because again, when you were a student, you didn't strike me as being one very concerned about what that looked like on paper. I remember you taking the safety system. We had just gotten all these safety components in because I had seen that at a trade show. And I said, well, I want to make one of those. So give me a parts list. I asked our vendor, give us a parts list, everything we need to build one of those. And everything came in. What we had then are the drawings for a different system that had been built somewhere else, not necessarily all the parts we have. Well, that seemed like a good challenge to you because you said, well, can I take this on and wire it up? And you were the first one to get our safety system working.
Yeah. Yeah. I mean, don't get me wrong. Like, I definitely was excited about the educational aspect of things and like pushing myself. And like, I also, on the other side of things, like not only did I want on paper to look good, but I actually wanted to be like, better than the next person. And,
Yeah.
a lot of that was just driven because I didn't, it was insecurities. It was like thinking I didn't, even today, like sometimes I'm like, holy cow, I have a degree. Like I almost even forget that I have a degree. And it's just kind of mind blowing that that's still like something that crosses my mind occasionally.
Insecurities, everybody has them in different areas and that, and you think that you can't do something. Every time, I mean, I was a straight A student for all of high school, and I was a high A student, not a perfect student in college, but I remember every syllabus that I looked at when I walked into a new class, I was just thinking, I'm never going to learn this stuff. It looked so far over my head and so daunting to me. And when you think about it, of course, it's stuff you don't know. Why would you be in the class if it was stuff that everybody already knew? And they walk you through it. This is terminology. Let's teach you about the terminology. So people can do a whole lot more than they give themselves credit for sometimes.
Yeah. Yeah. And also too, like, with it like being overwhelming, that it's a step-by-step process. It's not like you're not going to learn all this stuff in one day. It's going to be, multiple class sessions, multiple semesters. Like
and even like that safety system we were just talking about, I took what you had started. You didn't finish all the outputs on it, but the next class, okay, here's where we are so far. We need to document these changes. And then we never got to this part, never got it to work. So a subsequent class got that part to work. Today, we're at the state where all of the components work, the inputs work, the outputs work. And oh, by the way, let's add a panel view to it using Logix Designer, which is not what we learned in class. So today, one person took that on. We've had one person in the past work on that. So I gave him what he had come up with. And that first person told me there is no way to do this certain function. It's not available in this. Well, it is. He just had so many other things to work on that he didn't get everything done. So my very best students, very best alumni, we all still feel inadequate and like we don't know enough on things.
Right. Yep. Absolutely. What was the push that took you to education?
Well, getting laid off, I became a stay-at-home mom, and I said, that one's not for me. And I started thinking about, well, I'd always thought, I think, when I was going through college about teaching, but in a technical field, I did not want to go into teaching before getting out there and getting my hands dirty and doing it myself. Just didn't want to do that, especially being a female in engineering. A lot of times we are sidelined and given the paperwork side of things to do. And so many times I definitely feared not knowing enough or being seen as not knowing enough. So I wanted to get some field experience. Once I was staying at home, I think being laid off burns a bit. Am I good enough to be back in industry? Maybe I'm not. All those negative thoughts. And I thought that was a good time to make a change. So I went into teaching. I had thought all along that might be something someday. Well, okay, now it's someday. And what I found at Ivy Tech is that when we are in office hours, my bosses have always been really good about, you don't have to sit in the office waiting for students to show up. So I put a sign on my door, I will be in the lab. And I'm out here trying to make that next thing, Well, a student asked me, why don't we have a conveyor that brings the parts into the robot cage? I just haven't gotten to that one yet, but I've got parts, I've got a plan, I've got it in mind, or you can take it as a student project. We get to play with technology and build and make something better. We've upgraded so much of the equipment that I know every time you come in, it's let me give you a tour to show you what has changed. And that really filled my need for, I want to be playing with the equipment. I want to be seeing what it can do. I want to test its capabilities.
Yeah.
I've got the great advantage here that if I break it, it was a great learning opportunity, and nobody is standing behind me with that stopwatch telling me how much money I'm costing the company. So that's a great thing there. I did find something, I'd probably been working here 7 years or so before I discovered what adaptive technology is. And basically, I was looking for a way to get our students some service learning opportunities, basically be able to practice our skills on something that's of benefit to the community. So our construction department had done things like going out to help Habitat for Humanity. It helps them build their construction skills, helps Habitat. The nurses would help out on blood drives and vaccination clinics and things like that. The culinary students would do things where serving food and preparing food was there. But I was thinking, three-phase motors, what am I going to do to help the community with stuff like this? We're not licensed to go out and repair things in factories. I can't go to someone's house and say, do you have any robots you need me to repair? Maybe we will someday, but we're not quite there. So when we saw at a Public Education Foundation tech seminar, we found adaptive technology where basically we're taking toys and electronically adapting them so that kids with disabilities can learn cause and effect by hitting a big button instead of those little tiny switches in the paws. And those would break down because the kids would throw them. So we would repair them. We can do soldering, we can do crimping, we can trace down the circuits and figure out where the problems are. We used our laser cutter to cut out holes in a keyboard cover so that kids whose hands would shake or they wouldn't have the ability to hit the exact key they wanted on a tablet, it would block off in between the keys and help guide their fingers into the correct hole. We worked with the welding and automotive department on making a wheelchair where a student could stand up. He was an automotive student, so it allowed him to work under the hood of a car, and when a car was up on a lift, to be able to reach and be able to actually do all the things his fellow students could do.
Yep.
Different students, when they would have free time in class, they got done ahead of time. One made a external button to a keyboard because we had a student who only had one hand that could type. The other hand was not able to do that. So this allowed her to use her elbow to hit a button that would hold the shift key, basically, so she could make capital letters. Things like that, we realized with a little bit of technology, our students could really help people out.
Yeah.
We do a lot of 3D printing, and 3D printing trinkets is fun. But people saw they could use 3D printing to help people to make a hand for someone who was born without one. All of a sudden, the amount of time that they were willing to put into learning how to do these skills, it just really went up, because printing trinkets is fun, but helping people is a whole nother level.
Yeah, absolutely. Also, too, I think the 3D printing side of things is a very fascinating part of the industry that's, like, in reality, pretty extremely new. It's just now really accessible to mass population.
Yeah, the prices have come down on both the filament printers, where you can get one for $300. Filament is reasonable to buy. There's resin 3D printers out there that are affordable for someone to have in their house. There are many that you can build from kits, or here are the components, pretty much build things from scratch, 3D print your own parts. for another 3D printer. And you're learning new skills the whole way through as you're building your own 3D printer so you can build whatever it is that you want.
Yeah, absolutely. Absolutely. What kind of advice do you have for somebody who's trying to decide what they want to do for a career path?
I think people ought to look at the difference between careers and hobbies, because careers are those things. I need to make money. I need to support family. I need to be able to survive. And the jobs, if you look around, there are so many people retiring and so many more technology jobs available that salaries have gone way, way up. Before, people wouldn't even mention how much they were paying when they advertised a job. Now a lot of them do, and they're showing really high amounts. So you look at, if I learn a skill, I'm probably going to need to keep up on that skill because technology does change, but you're putting yourself in a situation where you can make a ton of money. There are different jobs. Some involve a lot of travel, some involve none at all. Some work in a factory, some work in an office. So as you learn about what's important for you, you can find that kind of job. As a female in technology, why is it that more women are not in STEM fields? Well, some of it is the atmosphere of, is it a dirty environment? Does it involve a lot of long hours, unpredictable hours? Does it involve travel? Does it involve working in critical situations when the line is down and people are yelling at you? Does it involve teamwork with hard-headed people who aren't listening as well as they should and missing a point? There's all sorts of things about the careers that you can look and say, this part is uncomfortable for me. But one, it's very broad. You can find a different area still in STEM, still in technology and manufacturing that works more for you. And it's in such demand that jobs are changing to help people.
Yeah, there's a ton of opportunity all over. And you definitely said like a good point is like kind of like understanding kind of maybe what you want to do and also like a career versus a hobby. One on the career side, I'll see like a mechanical engineer, we'll get a mechanical engineering degree, graduate, and then say, I didn't know I was going to have to work in front of a computer this much. And it's like, like it's kind of a little late in the game to figure that out.
Well, that's why I definitely say try to get an internship or a part-time job so that you can see what the job really entails. And then also, if that job is in front of a computer too much, find a different job in engineering. One of my jobs for me was too much in front of a computer, but it's a great job for someone else.
Yep.
So I can't say it's a bad job or a bad company, just it wasn't the right fit for me. So we got to be okay with learning about ourselves and saying, I'm not going to be the CEO of a company because keeping track of those finances day in and day out is not for me. You've got a lot of people who talk about starting their own businesses, and they may have a great engineering idea. But are you okay with either spending the time and the mental headspace on the business aspects, or going in with someone you really trust that will? Because you need that business acumen if your company's going to do well.
Yeah, absolutely. And like with starting this company, like one of the things that I highly underestimated was the sales process. Even though like our industry is still a booming industry, there has to be a lot of work going into the sales process, right? And then the quoting process and really just landing that purchase order and being able to execute the work, right?
Right.
Throughout my career, that's what I was. I was an executioner. I did the PLC programming, robot programming, project management, and much less on the selling of the system. Pretty much zero, right?
Yeah.
And,
Well, and you had the joy of starting your company when a pandemic hit. That's a time when nobody wanted to be hiring anybody.
Yeah.
Everything's on a standstill. So the fact that you launched your company and are as successful as you are, with that being your start point, that's ultra impressive. And I'm quite sure you didn't do that by saying, I'm not a salesperson, I'm the executioner. I'm
Yeah.
quite sure you couldn't get away with that.
Yeah, absolutely not. And also too, like my strategy completely changed because right when I started the company was right whenever they said we're shutting everything down, and it was like the day after type of thing. Um, and one of my strategies going into this was, okay, I'm going to go to events and network with individuals and get my name out there so that way people can know, just know who we are as a company. And also like with like leaving Midwest, we had basically an agreement that says, hey, just don't go after our customers, and then we're all good. And so I was honoring that, and so therefore it left me with pretty much zero contacts. I also did a terrible job at networking and facilitating contacts prior to leaving Midwest. And then on top of that, the contacts I did have were customers and whatnot that I could no longer have access to. So now here I am, starting a company with pretty much zero contacts, expecting to go to events, and that's where I'm going to land all my gigs, right? And COVID's here, and so I'm like, now what are we going to do?
What did you do?
Primarily LinkedIn. And I already had that strategy to some degree. I had already started working on LinkedIn a little bit before that, but it was just basically doubled down on that, right? I thought LinkedIn was going to be a smaller portion of what
Right.
was our driver, but it ended up being 100% of it for like a good solid year, maybe even two.
That's fantastic that you were flexible enough to find that separate avenue.
Yeah, absolutely. I mean, to be honest, like without it, I don't know what I would have done. I'm sure I would have figured something out because I'm a figure it out type of guy. I have a mural thing, right, that I made, and one of the things on that mural is the ability to figure anything out. And that's just like a powerful like philosophy to have, and if you can do that, you can figure anything out, right, no matter what the obstacle is.
Well, that's sort of reminding me of in school. A lot of times we start out with the beginner classes. Here's a lab. Today I want to teach you about this certain concept. Here's a lab that's going to demonstrate that for you. And I really like to get away from that, especially by the second or third course that you have in a subject, to get to figure it out. And I know many of my students are uncomfortable with that approach because I'm giving them, here's a project. I've never done it before. I don't know how to do it myself. You're going to research it, and I'll try to help you through the research, but sometimes we're going to get to something, neither one of us knows the answer, and we're out of time, so we'll go a different avenue.
Yep.
But that figure it out, I think, is super important for you and your job and many of the technician maintenance jobs that we have, especially with technology changing as quick as it is. There's never going to be, oh, here's the guide and this is going to have all the problems that you'll encounter in it. How do you recommend that people learn to think, learn to figure it out?
Yeah, absolutely. And like, the figuring it out process, the person doing the figuring out, they never like that process. And because it's something that I do to our employees, especially when they come to me and I don't know the answer, I'm like, figure it out. I said, if I got to do it, you know what I'm going to do? I'm going to figure it out because I don't know how to do it either,
Yeah. And there's certainly times where, okay, you already know the answer and we're just wasting time. You could just tell it to me. But a lot of times I don't tell it to them because I've said before, you need to read this manual. You need to look through this manual. You need to at least skim it so you know what sort of answers are there and the organization of it. So, when I'm setting up a VFD, parameters, I don't need to memorize all the parameters, but I should have an idea of what sort of things are set in the parameters, so I know to go and look in the guide for that when I need it.
Yeah, absolutely. Like what do I have the ability of changing?
Right, and many of the manuals, not all, but many of the manuals have a certain repetition to the design behind them. So once you start looking through them, okay, I know at the beginning it's going to tell me mechanically, how am I going to mount this device? How much space do I need in the control cabinet? Then how am I going to wire it up? Then do I need to set anything before hooking it up to a PLC? Then it's going to go through all of those different modifications that you can make to it. And then it's going to have the troubleshooting page, which is going to help you get back to which part did I find. I never find the troubleshooting sections all that useful. I find it much more useful I really need to look and see what is the machine supposed to do, which sections are controlled by what, and then go troubleshoot those specific areas. Troubleshooting guides, I can't connect to Ethernet. Well, go check your Ethernet connection.
Yeah. I mean, that's a lot of those things are like going to Google and checking forums.
Well, and I tell you, I think my students think that I'm just not doing my job teaching if I send them to Google. But I have found a lot of these manuals, especially if they have their file names are in some code that came up with within their company. I can go to Google and find the manual faster than I can find it on the official sites.
Yeah. Oh, absolutely.
So Google is definitely a great tool for us.
Yeah, absolutely. And also too, like, even to this day, I'm not much of a reader. I joke around with my kids and tell them I don't know how to read. But, like Control F, like being able to just like find stuff on like a digital version of something, like, okay, I'm dealing with an e-stop circuit. Okay, type in e-stop. Okay, there's, 200 instances of it, or maybe there's 27 instances of it. It's a lot quicker to just kind of jump through those and like kind of streamline that process.
Yeah.
And also, like you're saying too, where after you do enough research and documentation, you kind of start to realize there's kind of like a format. Like a lot of the documentation kind of follows like the same type of flow. Maybe it's not in the same order every time, but like they generally have like the same like key features within each one of them.
I find it interesting too, and I think it was probably you that I was talking to about how to wire something up. And so we bring out the guide, and of course, when we first tell the students we're going to wire this up, and here's a wiring diagram. Oh, I don't know how to read the wiring diagrams, and that start looking through it. But then you get to the point where I ask Malachi, tell me, how is it that you wire this up? Then you just sort of point to the page, and it's like, well, it's all right there. It's like, now it's so easy for you to look at it and understand it that you don't think it needs any explanation to me. Well, it says it right there.
Yeah. Whenever it comes to like anything that's like robotic cell related, I can pretty much just scan through like pages and just tell you what the title of the page is.
Yeah.
And that's kind of also another thing too that I think is super valuable is like, I always say to add more value than anyone else around you. And through that, like, it put me in positions where like I stepped up and I learned electrical engineering, and I learned how to do risk assessments. I learned how to do how to safely do the electrical engineering of safety systems and stuff like stop distances and all these different things. And in reality, like, it all started with just initiative, right? Just like hey, I'm gonna do this. We don't have anybody else to do this. And since I took on that initiative, I did some of those things on my own. They said, well, since you're the guy doing it, we're gonna go ahead and send you to the Rockwell RI safety
training.
Yeah.
Well, sometimes I know in classes I'll bring up, today I covered just a little bit of the TUV safety. And I said, we're not going to be tested on this. I'm not even going over it fully. I just want you to be familiar with some of these terms. And when we're looking at the safety system and you see, it has these false alarms. It's going to shut off and give us a fault so much more often. Why? You understand when we go through the safety analysis or look at the steps that the safety engineers have to go through and have to prove that this is safe for personnel, you start seeing why you get so many false positives.
Yeah. Or like say for instance, like your category level on your stops. Like why when I hit the e-stop button, it stops so abruptly? That almost seems more unsafe than if it just kind of coasted to a stop. And there's definitely instances like that. Well, I mean, a really good example is like PGW, when you have a piece of glass on the end of arm tool. Like sometimes like stopping abruptly is not good for when you're holding a piece of glass. These are things that you have to take into consideration and are good to at least have some understanding that they're out there. Like in all reality, like I'm doing less and less engineering as we grow as a company, and even those things for myself, I have to go look them up. Like if we're looking at stop category levels, I have to go look that up in a piece of documentation, but I know that it's there. I know where to find it. If I'm doing it on a FANUC robot, I know how to find it in the FANUC documentation to see where to change the settings to get the category level that I want. So a lot of things are just knowing that they're out there and knowing how to find them, and not being so pregnant on the fact that you have to know everything. You don't have to remember everything. I pretty much remember nothing, but I just know that I can find it somewhere and whereabouts I can find it.
I remember times have certainly changed with safety and what is built into the equipment. I remember at PGW, we had a large furnace, 5-stage furnace, and with the rollers, as the glass was moving along in the rollers, it's getting progressively softer and softer. And it keeps on going until it gets into a press, when it is pressed to its final shape. Well, if you have a power outage or for whatever reason, the rollers stop, that glass continues to sag and suddenly is, not able to roll because it has sunk down between the rollers. So the process at the time, they would hit a switch or a lever or something, the furnace would raise up, and they would put very large insulative gloves on, and with hooks, pull it out and just grab the glass as fast as they could and yank it onto the floor. So it wouldn't adhere to the rollers. And it was so dangerous. Here I am, a young engineer, just started there. I didn't know what was going on, but glass is flying. It's like, I need to make sure I'm not where the glass is flying to, get on the other side, but I don't, that was the best way to save the company lots of time and effort, because otherwise you'd have to sand those rolls down, get the glass off, sand them down, lots of quality defects. So I remember thinking, this is so unsafe. Someone could get hit by the flying glass, the broken glass as it's flying up. But boy, to make those changes on existing equipment, so expensive. And you got to look at, not only is it a big change in that, but the operators, are you hindering them more? Because we could have said, you are not allowed to raise the roof off and pull that glass out. But how dangerous is it, or how costly is it also to do it another way, to get that glass off another way? So I'm glad to see this kind of question being asked ahead of time, so that you can build that into the machine. Immediately, as soon as power goes off, brakes release that cause the rollers to go up, glass immediately goes down into a hopper below, and you can reset everything when power comes back up.
Yeah, absolutely. Much better approach. And instances like that where like you're working around dangerous things, that like anything that you can engineer in to be safer. Like another big thing was like on the robot tooling, I was a huge fan of doing individual vacuum lines. So if you basically inline vacuum generators, if you ran into issues where like one of your cups starts to fail, what would happen a lot of times is like, you know, you have one cup start to fail, you have a second cup start to fail, and then you start dropping sheets as the robot's picking it up and placing it. And
we had it on our lift assists. They wanted it nice and simple. If the vacuum was strong enough, we want a green light. If it's not strong enough, we want a red light. But the problem was that didn't give any kind of indication to maintenance on when to do PMs and that. So what you'd find is that you would suddenly go from I'm good to I'm bad, dropped a piece.
Yeah, absolutely. Going into the career side of things, what are some of your suggestions for people who are just now leaving college and how to navigate into a position of employment?
Okay. I see a lot of people not taking advantage of the services that we have here. We've got a job board. A lot of companies call us and say they've got jobs. Do you have somebody that you can recommend for it? We try not to recommend so much as present it to all students out of fairness there. And also, you know, we might not see everybody in all the different light. I never knew that you would be interested in starting your own business. So, you know, there's things that we don't know about the students. So we try to say, go to our career service. They will help you write a resume, review the resume, help you with perhaps a portfolio. Why do I need a portfolio? Well, for people who can do skilled things like the welders and the people who learn machining here, sometimes to show, wow, that is something that you created, and you can see the skill much better than a piece of paper can say, well, you've got a certification. So let those groups help you make that portfolio, make your resume, and do mock interviews. They will interview on video, and then you can play it back, and you can see how many times I said and you say, wow, that sounded, I had no idea I sounded like that. I had no idea that I did certain habits or whatever. It's great tools there. But I would say so many companies are looking. You can talk to your fellow students, talk to the instructors, but definitely look at the job boards. Get out there and do that homework. Put the time into the resume. Put the time into putting yourself above the crowd so that you can have the job you want, not just the job you can get.
Yeah, definitely like that resume process, like utilizing the services of that is super powerful. Like I use that service through Ivy Tech because I wasn't a resume builder, and in all honesty, if you took me back to being an individual coming out of college, I still probably wouldn't have the resume building skills, because like now I've came up far enough along in my career that I can write a resume that I feel like people would, this is what they want to see, right? Also, being a business owner and hiring people puts me in a good position as well to like, what do I look for whenever I go to hire somebody? Me, like part of it, like with me not liking to read too much, I don't like to see a lot of blah, blah, blah words. I want to see what can you do, you know? And then like another big thing that we'll look for is like, if they say something like installed robotic cell. Okay, cool. What part of the robotic cell did you do?
Exactly. All by yourself or you and your team? What was your role?
Yeah, exactly. And like digging down to like what your role is. Oh, I was just holding the guy's screwdrivers that was doing all the work, you know, like.
Back when I was interviewing for jobs many years ago, it was advised to us to put in dollar amounts. Save the company $200,000 by engineering this project. And, you know, that doesn't do a thing for me. Because it's supposed to give an idea of size. But again, I want to know, what role did you take on in the project? What skills do you have? What can you do? So I have seen resumes recently for people who want to teach telling me I managed a project of this many millions of dollars or whatever. And it's like, that doesn't tell me a thing about, do you know these concepts and can you pass them on to students? So
Yeah.
look into what is current in resume writing. I mean, the internet wasn't around when I started writing resumes, so things have certainly changed there. Learn how to do the things online. If they say, I want you to put in this application online and upload a resume, do that. You know, do it exactly as they say, because otherwise you might be weeded out very quickly for not following those rules. It's an easy way to trim the pickings if there's too many, but we're going to get so many skills in this field that that we'll be the only ones qualified to do the jobs.
Yeah, absolutely. I'll do one thing like kind of a good example of that is we will run job postings on LinkedIn, and then we also put in the copy of that, make sure to apply at eliteautomation.com/careers to be considered for this job. And if they don't apply, not only do we not necessarily consider them, but they don't actually go into the spreadsheet where we actually go to look to see the individuals that we want, because it lays it out nicely for us in our spreadsheet where we have like, job title they're applying for, years of work experience, whether it's, PLC programming background or like what brands. A lot of times we're looking for like what brands because we have specific needs. Like, we have an Allen Bradley project coming up. We have a Siemens project coming up, and we really need to fill the need of that project. And so if they don't take that extra step to go apply through our website, then they're essentially abandoning the job.
Yeah.
Another thing is too, like I highly advise people to get on LinkedIn, because if I'm posting a job posting on LinkedIn, a lot of times that's the only place that I post the job posting. So if you're not on LinkedIn, you don't see the job posting.
Good to know. And, as a job hunter, job seeker, it's not good enough just to go and put my resume out there in one job hunting site and hope that they all call me. Besides the fact that I know me best, I want to go out and seek those companies that I'll fit in best at. And you might think a maintenance job, same all over. No, not a bit, because some of the people that I have as students, they are allowed to really dig into, look at the root cause and try to come up with fixes to it. Other times, other companies, we just have time to fix it and move on. Some you can move up into leadership positions. Some that is your progression. You almost have to. Others, that might not be where you want to go, and it's not something there. So it's not like any of these job characteristics are necessarily better or worse. It's what do you want? For some to have to know mechanical and electrical, I have to learn two different things. For others, it might be great. I get to be more well-rounded.
Yeah, absolutely. We got a question from somebody. Basically, they were told that they're going to be trained to do troubleshooting and PLC programming on the job, but they're looking for another way to increase those skills outside of work. You have any suggestions?
Okay. Well, in some of our classes here, we definitely try to look into the troubleshooting, and I will point out once again that when a lab goes wrong, and it does at times, is that the time that you go out on break, or like Malachi, do you dig in and try to figure out, well, what happened, what's going on, and learn more about the system there? We're a nonprofit at Ivy Tech, and so we put it under the umbrella of Robotics Club. We've had people that have wanted to put together competition robots and go to a competition, compete for prizes. Mm-hmm. We had others that wanted to work on things such as the stand-up wheelchair, where we can bring in a lot of resources. We brought in help from machinists, from welders, from the automotive group. We teamed up with Easter Seals and did things there. So make it known what it is that you're looking for. And as a student, even taking one class, we can look at, well, what can we get you involved in that'll get you towards your goals? We've got equipment that right now is not being used. Could we work on troubleshooting with it? Sure, we can get things going. We've got a lot of freedom to do that. It got really quiet here, and I'm hoping that it's not that it froze. It did freeze, and then it unfroze.
Yeah, I think we're back. Are we back?
Okay.
Yeah.
I thought that must have been a great answer. I just totally stunned you into silence.
Yeah, glitched the whole system. Yeah, you also said something in the beginning there that I think was very important with the, staying like during break time, and something that's really powerful with that, like while at work. I mean, he mentioned after work, but also like while you're at work, like if there's any way that, like, if you have downtime, if you're like in a maintenance position, and a lot of times like maintenance positions, they have like a lot of downtime where they're just sitting. Well, if there's Billy Joe on line 3 working on something, just because you're over line 5, as long as you're not going to get fired for going over to line 3 and helping Billy Joe with his work, go with him and learn exactly what he's doing. Or if there's a programmer that's working on something. I mean, as long as, like, if you're going back to, if you're like maintenance, because a good example, if you have your walkie-talkie on you and you can roam the place a little bit, like maybe there's a capital project getting installed, and maybe you can sit with the guys that are doing the install on the and like doing the PLC programming, and like kind of just say, hey, what's the operation of the system? Kind of ask those type of questions. And then a couple more things is, like, you could sign up for community college classes after your work hours. Another solution is, there's some pretty good online PLC programming courses.
I was going to mention the PLC forums. Quite often when I've encountered a new problem, I'll get on PLC forum to look up other people have had similar problems as me. What kind of solutions did they come up with? And sometimes it's something crazy simple that we have to do to make things work. But that networking there can help us out. One thing that we talked about in class just the other day is, if you are getting trained as an operator in a company, you just started there, do you want the line to have lots of problems the week that you have someone there to train you, or do you want it to be running smooth? Now, my first answer was, well, I wanted to have lots of problems so that I can see the troubleshooting and I can have someone explain what's going on. And it was someone from Toyota who had corrected me on that assumption before and said, well, wait a minute. If you see stuff that's going wrong all through the week, then why don't you just fix it and that never happens again? I'm more used to we know what this is. Every couple weeks, this thing goes down because of this problem, and never get around to fixing the root problem. So I'd say my advice is, watch the equipment when it's working and see what it does. For example, I'm amazed at, sometimes a green light means everything's good and running. Mm-hmm. Sometimes a green blinking light means good. Sometimes a yellow light means good. Wait a minute, I don't even know when this, it's a yellow light. Is that good or bad? It depends on the equipment. So get a looking at it and learn what it looks like when it's working, so you can see, okay, it went down. Now that's yellow and it used to be green. Is that indicating something? Yeah,
absolutely. Familiarity with the equipment is so powerful. I mean, there's a lot of times, like, where we go on site as contractors, and it's a a day, maybe even multiple days of just figuring out the equipment, just having a good understanding of the code. And it's also another thing that we try to do as a company is like, we'll try to get the backups prior to going on site if we have to do like troubleshooting type of things or improvements, that we get the PLC robot back up and then have one of our engineers start to analyze and write down documentation of that. And also, if you're an individual working on the PLC code, if you can, like, maybe you don't have the PLC software, but if you have the ability to print like to PDF or something like that, you can print a PDF. You can take that home. You can start reading the PLC code. You can, start writing down a piece of documentation that says, hey, this code is for this process. This code is for this process. And it's a very good way to understand what's going on inside of logic. Me personally, I actually struggle with memory quite a bit. So like, if I don't like take notes of PLC code, like I'll get lost and like I'll get to thinking about this and I'm chasing something else down. And I was like, what was I chasing down in the first place?
Yeah.
But like,
I take a lot of notes, and for a couple of reasons. One is, for some people, writing things down, the process of looking at it, writing it down, or analyzing it enough to know what to write down is a good thought process to go through. Writing it down, and I draw pictures more so I can find that again. I don't always have to go back to those notes, but just the process of making them is helpful. But one thing I really like to do is write down my questions as I have them. Because when I first look at a new system, we're going to analyze a VFD today, and I'll write down, what's a VFD? I don't even know what it stands for. You're not going to need that note once you get a little further along in it, but it also lets me know as I'm teaching somebody new about this system, oh, you do have to go back and say variable frequency drive. You cannot assume that everybody knows all these acronyms that by now you're very used to, but the student isn't going to understand a thing if you jump in at that level. So it helps keep me knowing what order I need to go in. Not everybody thinks the same as me though, but I know I like to write down my questions and like, I want to know how to make the light go on when I press a button. That's the first thing I want to do on a PLC.
Yep.
Okay. Yep. So when we have lessons that go through talking about from a grand scope what all you can do with a PLC. Now, first I want to go and make it do something. Helps me to write those notes and saying, what do I want to learn first, and moving that stuff to tell the student first.
Yeah. Yeah, absolutely. Yep. Sorry, I'm going into deep thought for a second.
All right.
So what are some last tips and pointers you have for individuals?
Well, I would love for whoever wrote that question about troubleshooting to get a hold of me, because that could be expanded on. I love hearing from previous students who come back or email me and say, hey, ran into a new problem at work. I'll give suggestions, or I'll call you up, or use my network to try to find somebody who has had a similar problem. One great thing about the equipment that we have here, and whether it's during a class or just, hey, stop by and see if we can troubleshoot something, I've got numerous of the same thing. So you tell me you did this and this happened. Well, let me try it on another machine and see if it does the same thing. That would help me find out, is it a programming issue? Is it an electrical issue? So there's just a lot of tools that we can bring in with extra equipment, with networking, with talking to other people. I'm going to keep calling you up with all my FANUC questions. I've never run into this one before.
Yeah.
What do you say, Malachi?
Yeah, absolutely.
So use your network. That's my last advice.
Yep, absolutely. That's huge. Yeah, I would wish I'd have done more of it in the beginning of my career, beginning of my college. Like, we didn't mention it in this episode, but I try to harp on it on every episode, is like, LinkedIn. Like because LinkedIn is just like a directory of finding individuals, right? And like,
Yeah.
you could be a college student who just like vlogs like what you're doing in class, right? Hey, we're programming this, PLC to do this thing, right? And then if you go and apply for a job or direct message somebody on LinkedIn, hey, I'm going to apply for this position I seen open at your company. Do you know the person that handles the hiring? Or, hey, feel free to check out my LinkedIn account. And then, if they do, they see all these like vlogs and things that you may have done and worked on. And, one, they're going to feel more personable with you. And that's huge. That's something I didn't actually realize until starting a company, that like how like personability, there's individuals that maybe I've had a conversation with before that I might choose them over somebody else that has maybe a better resume, but it's just because I've had a conversation with them. We've had a dialogue. We've, built some small form of a relationship. And especially,
I might think more of that when I try to get all the students, as we're doing any kind of projects, I try to make them write reports on, write down who you did the project with, what was the goal out of the whole thing, but write down what equipment you use, take pictures while you're going, because a lot of times I'm not even thinking of this question yet. I can take a picture and maybe find the answer to it in that. But I tend to see people really hurrying through the report part. The documentation is just not of interest. I want to build the thing, or I want to solve the problem and then move on. And I wish I could get across better the importance of documenting what you're doing, because it might be, again, for a portfolio. You need to show that you have experience on a certain kind of robot. Well, let me show you. I don't really remember this project, but I can go back to my documentation of it, pull a picture or two. I can put down what that project scope was, or what the main thing I learned. So I wish I could get across better to people. You're not going to remember the nitty gritty of what we did in each of these labs, but you're learning something each time, and write down what it is that you learned.
Yeah, absolutely. And one other thing that's like really powerful in that documentation process, we as a company, and I personally love like Google Suite products. So like utilizing Google Drive mixed with Google Docs, and like, you can have robot code that you wrote, save it to Google Drive, PLC code, save it to Google Drive, and write documentation, put a link to your Google Drive to where that robot code is, write some more documentation. Here's the link to your PLC code that's on the drive. And now all these things are in one documentation. They're one click of a button, and you can access these other files that are associated with that project. Pictures, our whole drive system is based on that Google architecture of like, the way our project folders are named. We have like, our EE, our ME, IMG for images, and like all these things are within the drive, and have, can have a drive link associated with it. So whenever somebody messages me and says, hey, I uploaded the pictures to the drive, I know exactly where to go find them. And they can go ahead and share the link right then and there. So it's a click of a button for anybody.
And I love that if you write a document and I have comments on it, I can easily put those comments in. You can decide which ones to ignore, which ones you might go a different direction or whatever, but you're not losing, oh no, I accidentally deleted an entire paragraph. And you can get back that old document, and we don't have to say, which version of this is the latest one. It does a great job on that. So we use it quite a bit as well.
Awesome. Yeah, it's definitely a powerful tool. Good deal. Well, Donna, this has been a great episode, probably one of the best ones.
It is great to catch up with you.
Yeah, absolutely. Guys, thank you for being on our podcast, and definitely thank all the guests for being here and asking questions. We'll catch you on the next one.
Thank you.
Oh, hold on. Before we catch you on the next one,